We saw before in the GDCOR project that the GPD forecasts included coordination and the effects of concurrent dependence, which is wait, causing two of the teams to wait. How can we improve this project? If we find the team is waiting, what should we do? Should we change their team size? Should we do something to someone else? Let's take a look. As you recall, we were looking at, in particular, the mechanical and structural engineering team, which was waiting. We identified when they were waiting, which was in late April and much of May. And since now we know where, we went to the Gantt chart to see what particular relationship or dependency is causing that wait. We saw in April and May that the structure and interior design was the task they were working on. By showing coordination, we could drill down to which team they're waiting on. In this case, it turns out to be the engineering team as they receive information from the preliminary design and the electric motor hub design. We confirm that by looking at the red line, the predicted forecast, and see that it overlaps or is being constrained by the blue area of the dependency. Okay, so what can we do? Do we change the team size downstream or upstream? Should we somehow make 9 go faster? Or maybe we can make 10 go more slowly. Anything to lift that red line off of the constraining blue area. So we go back to the designer model. We can see the engineering team has 6 people. So let's try to make that go faster. We see mechanical engineering has 18 people, but 32 hours a week. So let's try both. We're going to make the upstream team engineering a little bit faster by making it 8 people, so they have more capacity, and therefore they should have more throughput. And downstream, we want to have fewer people waiting. That's going to help on cost. So we're going to reduce that from 18 to 15. So this is more than one change for a scenario. And we want to see if we're balancing both speed to reduce duration and cost. And if we get it right, we're going to have improvements on both duration and cost. So here we're going to run a simulation with this new scenario with 2 more people on the engineering team and 3 fewer on the mech and structures team. We're going to run a GPD forecast using stochastics, just 5, so it doesn't take too long. And as we wait now, we can see the simulator has started in the cloud. We're waiting for those simulations to complete and for it to generate a full forecast. We now have done that, so we open the forecast, and it's still showing the previous forecasts, which we looked at. So let's remind ourselves quickly where we were. And now we can open up the new one, and we see a new, in this case, number 21, forecast that is shorter by a month and several $100,000 less. So we had a net impact. Let's open that forecast up and begin to see where that occurred. Right away, we can see for the mechanical and structural engineers that they're proportionally waiting much less. The engineering team is not waiting. We use them efficiently. And I can examine the Gantt chart as well to see whether the whole timeline has been shifted. And if I drill down for that team that was waiting, we can see that they're still waiting, but the distribution and the duration of that wait is much less. So we found a pretty good compromise between the trade between, in this case, speed and duration by affecting a reduction of wait due to concurrent activities. Why don't you give that a try for the other team that's waiting and see if you can improve the project by making 1 or more changes?